Hello, folks. I hope you can see this. Today we are going to speak about first order and high degree differentiation equation. So we started with the first order and first degree differentiation equation. Now today we are going to introduce for you guys a different topic that is first order and high degree differentiation equation. Okay? So first we have to see what is degree and what is order. So if you just roll down all the way in the same channel in V-Numericals, you will find all of these definitions. Okay, in section of Math 2. Okay, you can see there, and yeah, this is still part of Math 2 syllabus. And we are going to discuss today first order high degree differentiation equation. So mainly speaking about first order and high degree differentiation equation, first it is an equation that you have a first order. Okay, it means that the higher differentiation term in this equation is of first order, mean that is 1. We are just having here terms deriving only one time, but this term that is deriving one time is repeated, okay, here, okay, with higher order. I mean, it is resting to a power n, and n is usually more than 1. Okay, so suppose n is 2, n is 3, 4, 5 till infinite. So this is the general equation for first order high degree differentiation equation. Okay, then let's jump. Okay, if you can see this one. So this a, okay, are standing for nothing more than our coefficient. Okay, these are constant coefficient. Okay, so and the next query that we will rise up here is so now how to solve when we have first order high degree differentiation equation, how to solve them. That's the point. So to solve this, we will work, okay, only upon basic methods to solve this one, because actually we have more than 3 ways to solve this high degree first order differentiation equation. We have more than this way. So I'm going to just introduce these 3 methods, okay, these 3 ways to solve this differentiation equation, this kind of differentiation equation. So stay there, and I hope you can enjoy this lesson. So today we are going to see how to solve, okay, for this first method, because the first method is you have to solve like solvable for p by making p equal to dy by dx. Okay, so here in this method, what we have to do is only like changing wherever you find dy by dx, you will change by p. So if you do this one for this first order, general first order high degree differential equation, if you just change p by dy by dx, just put here dy by dx, dy by dx, dy by dx. What is dy by dx? This is p. Put the p here, and p here, so on. What you are going to have, see, I'm solving for p, okay? I'm starting for solving for p. So this is one method to solve. Then we are going to do this one, then solvable for y, okay? Yeah, the main query here will be how to see whether this function is solvable for p, for y, or for x, okay? And this will be the CERN, okay, of our discussion today. So solvable for p, okay? The first thing we have to do, okay, if we are solving for p, we have to make this equation in terms of p. And who is p? P is dy by dx. So just substitute in star, in this equation star, I will substitute p equal to dy by dx. Okay, where I find dy by dx, put p. Then what we are going to see, this one will be p raised to n, then p raised to n minus 1, then p, and so on. This is what we are going to have here. As you can see, it will be an p raised to n, an minus 1, p raised to n minus 1, plus, and so on. Then a1, p plus a0, and so on. So if we are solving for p, it means that our, how can I say, our variable here is p, right? So what you have to do, we are just to find, okay, actually, I just forgot something here. Let me just, okay, this is multiplication, okay, of any terms. Then we have here p minus phi n equal to 0. Okay? Okay, this way. So see, here we will have what? Here we will have p minus phi 1, p minus phi 2, and so on and on and on and on. Okay, we have any roots for this equation. Okay? This equation that can be solved by p only. So next step, after writing it this way, so the next step is, okay, this will be the solution, okay, like partial solution, not total solution. P minus phi 1, p minus phi 2, and so on and on. So this will be the partial solution. Now, the equation is in form of dy and dx, so we have to express the solution in terms of dy, in terms of y and x, okay? So after solving, after putting comma phi or p in this way, what you are going to do, you are going to substitute here your p value. What is your p? P is differentiation of y with respect to x. So you are going to find p equal to dy by dx, okay? What you are going to do, solve each differentiation equation, because this one is a differentiation equation, this one is a differentiation equation, okay? And this one is also. So if you put, instead of p, put the real value of p, dy by dx here, you are going to have p, that is dy by dx, minus f1, or minus phi 1 must be equal to 0, and this must be equal to 0, this must be equal to 0 too. So here you are going to have many different equations, okay, of first order and first degree differentiation equation. You are going to have first, second, third, according to the number of degree you have there, okay? So p minus phi 1, p minus phi 2, and so on and on. So if you just, to find the solution, just substitute the p value, then equalize this to 0, yeah, make it 0, and make it 0, and make it 0, okay? Then solve this equation. You are going to have a general solution as a function of y, that is dependent variable, x, c equal to 0, okay? And the general solution will be actually, okay, a function of this, okay? And this will be in product, because you are going to solve this and multiply this and this and this and this and so on. Now, the next question, okay, the next point is, now that it is solved, okay, let us just take one exercise, okay? We will analyze this, all of these exercise, okay? We analyze all of these exercise, this one, this one, this one, whether it is solvable for p or not, okay? Stay with us, stay linked. Okay, now I want you to look closely to this equation right here, okay? If you can see, here we have an equation like this, okay? The first equation is dy by dx square sine of x plus cos x dy by dx 1 by 2 sine of 2x equal to 0. This is the first equation, okay? And this is the second one, this is the third, fourth, 5, and the fifth. The first thing is how to solve this equation. The first, how to solve this equation, okay? See, the first thing you have to see, okay, to start solving any differentiation equation is what is the order and degree of this equation. Which kind of differential equation is it, okay? As we can see, here we have higher order, okay? Higher order, first degree, higher degree and first order differential equation, because we have only once. It is dy by dx, it is only once, repeated once, okay? This is first order, okay? But higher order, higher degree, which means that the degree here of this differentiation equation, of this differentiation term, is, that is the maximum also, is only 2. 2 is greater than 1. So it is a higher degree first order differentiation equation. Nice. Now that we know this, what we are going to see, let us see whether this function or this exercise is solvable for P. Okay, what is the first step? The first step is, like, let me write down dy by dx square, okay, minus sine of x plus cos x dy by dx plus 1 by 2 sine 2x is equal to 0. So what will be this one? How to solve this one? That's the point. First I have to check, is that equation solvable for P or not? So the first thing we have to do is substitute your P there and see, okay, substitute your P. What is P? P is dy by dx, okay? Just let P be dy by dx. Just substitute this one in this. So you will see that you are going to have a polynomial expression, okay? Just like this. Put here P, and these other terms will remain the same, okay? So what you're going to have P square here, then minus sine of x plus cos of x, okay? Then P here plus 1 by 2 sine of 2x equal to 0, okay? Here we have a first degree, we have a polynomial of P, okay? Polynomial in P. So what you have to find? We have to find what is P1 and P2, because this polynomial has 2 roots, okay? Yeah, because the degree of this, the higher degree of this monomial in a polynomial will indicate the degree of your polynomial. So degree here, higher degree is P. So the question is that solvable for P? Yes, it is, okay? Because here I cannot find a direct way to solve for x, as x is in a very complicated trigonometric expression. Now see, what we are going to see, this is a polynomial of P. We have to find what is P. C, you have 2 ways, okay? You have 2 ways here. You can solve it either by, you know, Bhaskara formula, like if you compare this polynomial here with this expression over here, ax squared plus bx plus c equal to 0, just compare them and you will consider here, this one is a polynomial in x, okay? But this one is a polynomial in P. So whatever is going to happen with x is going to happen with P also. So by this way, you can check whether this polynomial is, how can I say, is reduced, or we can factorize and we can just make common factor of P or not, okay? But for this case, we have to understand a little bit of, how can I say, we have to understand a little bit of some trigonometric identities, okay? Even to choose this one. So you can either go this way or in another way. But if you go for this way, do not forget that this A here will be 1, this B will be this expression here, apart from P, okay? All of this expression. And this C will be this expression over there. And if you solve, first you have to find what is delta. Find what is delta. It is B squared minus 4AC, okay? Then after finding delta, you are going to find what is x1, okay? Okay, x1 and x2, that will be minus b plus or minus root of delta all upon 2a, okay? You can find this equation by this, okay? But I will not use this one. I will use some identity trigonometric, okay? So you can solve for this way, by this way, okay? You can do this one in this way, and it will be solved also, because in this way you will have this one delta for this guy. It will be this expression, that is b squared. This expression is b squared. This will be minus sine of x minus cos x square minus 4a. Here a is 1, 4a c. C is 1 by 2 sinus 2x If you solve this one, this guy will be positive, all positive. This will be sine square of x plus cos square of x plus the double 2 sinus and cos, okay, plus 2 sinus and cos, minus, here if you multiply 2 and 2, you get out, okay, you got 2 sinus of 2x. You see what you're going to have? This expression here, we know it is 1 plus 2 sin x cos x. It is the same as sinus of 2x. So minus 2 sinus of 2x. You see? And this one, what will it be? It will be 1 minus sinus of 2x. So remember, 1 minus sinus of 2x. What is this? This 1 minus sinus of 2x is the same as this one. Okay? I don't know if you can remember. This expression here, okay, is equal to this. Do you remember? Now we have just changed this minus. So it will be what? If it is like this, so it will be sine of x minus cos of x squared. If you do this expression, if you just multiply or if you just play this, you are going to end in this expression too. So knowing that this guy is square, then put there, because delta of root, delta will be under root. When you start to find this one, P1 and 2 will be minus B plus or minus root of delta. So see, delta, it is square. Square, you will cancel out, then you will find the expression actually. Okay? You will find P and P1 and P2. Okay? But you can use this one, or, okay, if you know very well how to play some algebraic identities, then it's okay for you. See, here we have this expression, right? What I'm going to do is to transform this p square minus this expression, p square minus this one, in a perfect quadratic, like when I have this one, a plus b, or a minus plus or minus b square is equal to a square plus or minus 2ab plus b square, okay, plus b square. Is that true? Nice. So this is what I'm going to see. Here I have p square, okay, p will be my I, my a. I will consider p as a a. So p is a. This p again, this is a. So it means that here it is missing what is 2 and what is b, right? So if it is missing what is 2 and what is b, let me write here down, outstep, like it is a square, okay, minus 2ab plus b square. This is equal to a minus b square. Now see, what we are going to do, we will just try to find this identity here, okay? We will just try to find this identity up right here. So how to find? Here we have p square, it's nice. What is missing actually? What is my a? A, I know, a I will consider as p, okay? Then I have 2ab. See, here I have p, and this must be our b, okay? This will be our b. So if this is our b, it must hold 2 also. How to find out? This will be minus, I will add 2, okay? Then in this expression, sine of x plus cos of x, I will take this 2 by 2, then I will multiply by p. In this way, I have what is a square minus 2ab. Nice? Now that I know what is b is what? Sine x plus cos x by 2, right? I have to write b square so that I can just grab in this way. Okay? Just like this. Then I will do this plus, okay? I will add this expression square. This will be sine x plus cos x by 2, all square. And this, okay? I add this expression, then I have to take Because in math, we do not add anything from nothing, okay? This expression, okay? I add this one, then I will take minus sine x plus cos x by 2 square. Okay, as I did here, I add and I take. Here also I add it and I take. Then plus 1 by 2 sine 2x. It is equal to 0. Okay, now what's the next step here? The next step here is just to put together. This one is a perfect quadrant, okay? Like this one can be written, okay? Can be written in this way. This will be P, A minus B, like A minus B. P minus sine x plus cos x upon 2 square. Then here, I will do the same, okay? This is sine x plus cos x all square. And we know what will it be. Then it will be minus. This one will be, we know that A plus B square is what? A plus B square, let me write. A plus B square is A square plus 2AB plus B square. Okay, this is A, this one. So this one, it will be, this one here will be minus sine square of x plus cos square of x plus 2 sinus x and cos x all divided by 4 plus 1 by 2 sine of 2x equal to 0. Okay, 1 by 2 sine of 2x equal to 0. Now, what's the next step here? I need space. Okay. So, here, you are going just to find this common factor. This and this is equal to 1. Okay. So, this will be P minus sine x plus cos x all upon 2. Then, minus square minus this and this will be 1. And this will be 2 sinus of x cos of x. It is the same as sine 2x. Okay? Then, see, this one. This is by 4. And this is plus 1 by 2. Find the common denominator. If you find the common denominator here, just multiply by 2. And 2 here, 2 down. 2 up and 2 down. We are going to have 4. Okay? Let me just extend this one. Then we'll have 4. 2 here. Then it will be what? It will be 4. Okay? Plus sine of 2x. 2 times by 4. It's okay? See, after you getting this is fine. This is okay, right? So, I hope you can get this one. So, what you have to do, just solve this expression here. Okay? I will erase this one. It's fine. It's okay. Just erase this one. Just play with these two. This minus is playing with this and this. This minus is not for this one here. Okay? So, I will repeat this one. P minus sine x plus cos x all upon 2 all square minus this. When you play, it will be plus, then all here by 4 minus 1 minus sinus of 2x minus 2 sinus of 2x. You see? Yeah, this is equal to 0. Equal to 0. Nice. This is plus. Okay? Plus. Plus. Then play these two. Okay? Play these two. You can play this. So you are going to have this P minus sine x plus cos x upon 2 square. Then, see, this and this will be what? This and this will be minus 1 sinus, this sinus, minus sinus 2x plus 2 sinus 2x. It will be directly, will be just what? Plus minus 1 plus sinus of 2x all by 4 equal to 0. Then you can just come here, P minus sine x plus cos x all upon 2 square. Take out minus. So you get minus what? This expression. 1 minus sine of 2x all upon 4. Now, what does this expression makes you remember? That's the expression. What does this expression makes you remember of? See, this expression here, it is the same when I have 1 minus sine of 2x, okay? Okay, 1 minus sine of 2x. Do you remember what happened here? Let me see, there is a way, there's a place, okay, this. When we make it square, this expression squared, we got this expression here. And what is this? This expression, this and this is 1, sine of 2x. It means that sinus x plus cos x, okay, square is equal to 1 plus sine of 2x, okay? If I take this one minus, so the only change I will have here, it is here, okay? It means that 1 minus sinus of 2x, okay, is the same, is equal to what? Sinus of x minus cos of x squared. This is the same. If you want, you can just try to prove this one. So you can just come here and see p minus sine of x plus cos of x by 2, okay? Then it will be minus, okay? This 4 is also 2, okay? Because I'm just trying to raise all with the same exponent. Then here we have sine of x minus cos of x all by square equal to 0, equal to 0. Okay? So from here, what do we have? Okay? From here, if you see it well, it is a like quadratic, difference of quadratic. Okay, we have two quadratic expressions like that, and this is a difference of this quadratic. Okay, whenever we have a, let me write this one. Whenever we have a square minus b square, it is a minus b times a plus b. Okay, this is what we are going to have there. So let me check what I can write here or not. Okay. Okay, so as I was saying, like here we have this expression right there. This is a difference of quadrant. So we have this one and this one. This is like a minus b, a square minus b square. And this one will be equal to a minus b times a plus b. Okay, then just do this one. And what you are going to have, see, here you are going to get this expression. This plus this one and this times plus minus this one. So if you just do, you get p minus, okay, you get, let me write down up here, okay, let me see if there is space, no space, I will write here down first. So here we will get p, okay, minus sine of x plus cos of x by 2, then a plus b, or a minus b, then a plus b, then minus, okay, sine x, okay, minus sine x minus cos x all by 2. Okay, here it is a minus b equal to 0. Then here I will write the other part, like p minus sine x plus cos x by 2 plus sine x minus cos x. Okay, let me do this one, p, because I'm lack space, okay, minus sine x plus cos x by 2 plus by 2 sine x minus cos x. Is that okay? Yeah. This way, okay, guess it is okay. So if you see this well, if you can see, okay, just if you can see, you will notice that there we have this expression, okay, this expression down. So what is the next step then? If you see very well, see closely, this minus is multiplying this sinus and this cosinus. So it will minus sinus minus cosinus. Then this sinus is positive, this sinus is negative. This and this will going to be cancelled out. And this minus here will be minus cos will be the same as I write P minus here minus cos minus 2 cos. 2 by 2, it is only cos of x. And the same will happen here, minus sinus and minus cosinus. Okay, so minus cosinus here, minus sinus here. Then minus sinus minus sinus. It will be minus 2 sinus over 2. And this minus cosinus, minus and minus plus cosinus. So minus cosinus plus cosinus, 0. This and this will going to be cancelled out. But this and this will be minus 2 sinus. Minus 2 sinus by 2, it will be only P minus sinus of x equal to 0. You see? Okay? This will be P minus cos x times P minus sin x. Okay? Then what is the next step? Okay? Now that we reduce this polynomial in a way like P minus phi1, okay, and P minus phi2 equal to 0, as you can see there. Now, P minus cos x, P minus sin x is equal to 0. Now we have to find this differentiation and this differentiation also. This is a first order, first degree differentiation. Remember, P is equal to dy by dx. Okay? Now, by putting this P here, what you are going to have? You are going to have dy, okay? This expression is equal to 0, this expression is equal to 0. So, you get P minus cos x is equal to 0, okay? As well as, okay, and P minus sin x is equal to 0 too. Let me just make this division upon here. You see, P minus cosinus is equal to 0 and P minus sinus, okay? And P minus sinus is equal to 0. So we have to put this one dy by dx. Now it will be dy by dx minus cos x is 0. Okay? This is for the first equation. Remember here we have two equations, okay? Two equations. Wait, let me just divide this one. Okay? Here we have this P minus this and we have this one. So what you're going to see, I'm first solving for this one, the first one. So just send this guy there, okay? Send this guy there. Dy by dx is equal to cos of x. Then here I can separate the function of x with the differentiation of x too. So we are going to have dy is equal to cos x dx. Now apply integration both sides. What you are going to have? Differentiation. Y is equal to, what is the integration of cosinus? It is sinus positive. So it is sin x, okay, plus c. This is the first solution for this equation. Okay. Now we are going to calculate for the second one. Okay. For the second one, we have dy. Instead, in the place of t, we are going to put dy dx. Dy dx minus sin of x is equal to 0. Here we will do the same. So dy by dx is equal to sin of x. Function of x can be separated with differentiation of x. So dy is equal to sin x dx. Now integrate both sides. What you are going to have? Y is equal to minus, okay, integration of sinus is minus cosinus of x plus c. Okay, Now see here, as this one is for the first equation, I will put C1 and here C2 because the number of solution, okay, that we have is also represented by this arbitrary constant. Suppose we had 3 solutions, so C1, C2, C3, and so on. So what will be the given, general given solution? We have y is equal to sine x and C1, and this one. So the general solution will be the product of this zero. Send this guy all here, okay? Send this guy all here, out there, and make it equal to 0. Make it also equal to 0. What we are going to have, okay? What you are going to have, this one and this guy. Just make them equal to 0. If you make this y equal to 0, this will be y, okay, minus sine x minus C1 equal to 0. And the second will be y, okay, this is the first, and this is the second, y minus, y plus cosinus x minus C2 equal to 0. So the general solution will be what? This product, this and this, equal to 0. So this will be our general solution. Will be y minus sine of x minus C1. Okay? It will be y minus sine of x minus C1 times y plus cos x minus C2. Okay? C2, it is equal to 0. Okay? This will be our general solution for this equation, as you can see here. Okay? Y minus sine of x. Hello guys. See, I will just do some basic concept on how to see whether the function or whether the first order high degree differential equation is solvable for p, x, or y. Okay, how to see this, how to check this part. This is what we are going to see in this video. Because the last video we just solved for p. Okay, now I'm just giving a hint on solving for x and solving for y. Then we are going to analyze just to check which are the methods that are possible to solve all of these equations up here. Okay, I'm not going to solve all of them. Okay, maybe the next video I will be solving all of them. Okay, or some of them if there will be time to do this. But what I'm going to see, or what I'm going to do, is just to check which method I can use to solve this equation or that equation or this or this or this. Okay, which method do I use to use? Okay, that's the point. So let's go. So first order high degree differential equation. Okay. Here we are just treating 3 different cases. Okay, 3 different cases, 3 different ways to solve this. We talked about the first one that was solvable for p. Okay, now today we are going to give a hint on solvable for how to solve it with respect to x and how to solve it with respect to y. Then c. As we said, okay, when we are solving with respect to p, we have to transform the entire differential equation in a polynomial of p. Then find the root of this p. Okay. After finding the root of this p, we know what is p. P is dy by dx. Okay. So if p is dy by dx, so this root will be a first order differential equation. So first order first degree. So solve this first order first degree, then put all together, the solution is given. Now for solvable, now we are going to speak about this different method. Okay, so we say like first a differential equation that is high degree and first order can be solvable also, okay, solvable for x, or we can say for y first, okay, can be solvable for y also. So how to check if it is solvable for x or for y? What is the step? Which are the steps that we have to follow? First, to solve for y, any first order, high degree first order equation, first you have to see, okay, if it is to solve for y, first step is just, you have to find what is your p. P is like dy by dx, okay? This is the change that we have to do. Then, in the equation, okay, in the same equation, you will do what? You will solve for y, okay? You will solve the equation for y. You will consider, okay, y. You will consider y as a function, okay, as a function of p and x, okay? You will consider y as a function of p and x. Then after considering y as a function of p and x, okay, and this easily can be solved when we have, okay, a expression of y like that. In this, suppose you have this expression here. When do I know that I have to solve for y or for p or for x? Okay, later on I will come on this. Okay, first let us just see how to solve. Then we are going to when to apply this one. So we have first p is equal to dy by dx. This change here, this substitution here, will work out for whether we are having for solvable solvable for p method, solvable for y method, solvable for x method. This is the first step. Okay, we have first to transform p into dy, or p equal to dy by dx. Okay, just like this. After transforming p equal to dy by dx, y must be equal to a function of p and x. If it were solving for x, then I could be here. I would get here x equal to a function of p and y. Okay, just the same. So now that y is a function of p and x, we then, the third step is deriving. Okay, we make this dy by dx. We will derive y with respect to x. Then we will find this derivative also. Okay, find the derivative of this guy. Then this function will be an f greater f. Okay, of p and x also. It will be p. It will be x. Then it will be what? Sorry. It will be x, then it will be p, then it will be dp by dx. Okay? So, because when we derive, we will get dp, also, okay, we will get dp, okay, dx with respect to x, then dp, okay, with respect to x, then we will get some function, or we will get a point of p only. So I'll get 3 variable now. Okay, this is the proof that we are going to have, and we will see this deeply or simply when we start solving problems. So the next is like after solving for this one, what do we have to do? That's the point. Now see, after getting this, you have to substitute, make this one going back to this. So you know that dy by dx is what? Is p. So it will be p equal to f of x p dp dx. Okay, here the order you can change it. Like you can have p and here x. Okay. Why am I changing? Because p here will be our dependent variable. Okay, and x will be independent variable. So first dependent variable, then independent variable. It's okay then. Okay, this is p because dy by dx is p, then dot of the one. After doing this, you are going to get another function. This function will be directly f, and this function will be, if you send this guy to this function will be also the same as a function of what? Of p, dependent variable, x independent variable, and dp dx equal to 0. So as you can see, from here, sometimes you do not need to go after this differential equation, because this is a notation for this is a notation. If you send this guy by this one, this will be also a function of fp dy dx. So this will be fp x dp by dx equal to 0. And I can call this f, or I can just call this another function, like it can be g, okay, g of p, and so on and on. The most important thing is just to know that whenever you send this guy to here, this will be 0, and now I'll have a function here. 0 will be a function g that will be also a function depending on p, x, and dp dx. So okay, now from here, whatever you're going to do, what you're going to do, yeah, from here you can just directly find what is your p, okay, yeah, sometimes there's no need to calculate or to find what is this differential equation directly. So sometimes you have just to find what is your p and separate p, and whatever that p that you are going to get with here, then substitute in the main, okay, in the main equation that they gave to you. So after solving this, you are going to have a function of what? Of y, x, and of y, x, and c equal to 0. That is your general solution. Okay? General solution. General solution. Okay? That's the point. If you are solving for y, this is the thing that you are going to do. But now, how to see whether this function is solvable for y or not, for p or not, for x or not? Okay? Let us check. I will pick up a solution here. I will pick up a point here. Suppose you have this, okay, this expression here. Check whether you can see a y up there. Okay? You can see a y up there? No, no y is here. So this is impossible to solve for y. Okay? Then the next one. Okay? This is impossible to solve for y. Even if you put p equal to dy by dx, here you got p squared, then x for x, then x to the power 4 to x squared plus 1, and this one. So here, as long as these guys, all of them are x, so you can send x in that side and you can solve it for p. Okay, this is more applicable for p. Okay, you can send just this one out there, then send this guy there, and you can solve for p. You will find two terms for p, and things will be okay. Things will be fine. Okay. Or if you don't want to send this guy there, from here, okay, from here, this is p squared, you can just find this one common root x and solve this guy. This is okay, if you feel like. And this one, if you can see, dy by dx is p. If you substitute dy by dx is p, so it will be p squared minus 4 equal to 0. Directly, everyone can see that it is only solvable for p. Okay, okay, it is only for p. Because there is no terms in y or in x. Okay. Now, Veloso, how if we get, okay, what about if we want to solve for solvable, okay, for solvable for x, okay, how to do when it is solvable for x? What are the steps? The steps are almost the same. Okay, first you have to make like p is equal to dy dx. Then you have to make another step is like separate x as a function of p and y. Then find the derivative of x dx with respect to y. It will be f. Here will be p y. Then dp dy. Okay, then the steps are the same, like very same. Then from here, you know that dy by dx is 1, is p. Okay, is p. Now, when I get this opposite side dx by dy, it means that this is the opposite also of this p. Okay, this is the opposite of p. So here we make 1 by p is equal to a function of p, dependent variable, y independent variable, ddp upon d dy. Now do the same process. Make this one come here. This will be 0, and this will be a function of py dp dx. So let's call this, I can call any function like j. I will call this h. Okay, and here it will be p y and dp dy equal to 0. So here the general solution will be also given like y, okay, x and c equal to 0. Okay, this is the same. Okay, the steps are the same. The only difference here is just this one. So as dy by dx is 1, so 1 upon dy by dx is dx dy, that is 1 upon p. This is the same. Okay, so how to see whether it's solvable for x and y? So that's the point. See here, is that solvable for x? That's the question. No, see, usually it is solvable for x or for y when you can find, okay, it easily, okay, you can find it easily, or easily when you can find it very difficult. It is very difficult to factorize or to make this polynomial in terms of a p polynomial, so that when it is difficult for you, okay, difficult for you to factorize this p and make this polynomial of x and so on. So there is x and there is p. This polynomial or this equation can be solved either by p or for x, okay? But for x, here we have x to the power 4. This is a very difficult to you to solve by x or for x. So if I were you, I would solve in a different manner, okay? I will get in a different way. That would be very easy if you go for p, okay? So for p, yeah, because p is square, this all will be constant, so here you'll get this one. We are going to solve this exercise also for p. Now dy by dx, here there is no x nor p, so no x no y, only dy by dx, that is p, so here it is only solvable for p. Y minus sinus dx dy, x plus dy dx. In this case, in this particular case, okay, this should be easy for you to solve with respect to y or with respect to x. Okay, y with respect to y or with respect to x. Very simple. The reason is very simple, because y here is a linear. Okay, we have y linear and x linear. So when y is linear and x is linear, so it is easy to you to solve with respect to y or with respect to x. Here the same. If you look at this, you'll see root y minus px time or into 1 plus p squared equal to p. See, if you try to solve with respect to p, what you are going to get, first you are going to make this one square so that this root can be out. Okay, and this will be p, this will be how can I say, a polynomial with degree 4. And this one, when we time, you will with degree 5. So then this one. So it will be a very long and a very complicated polynomial to you to solve, okay, with respect to p. So go for this y linear and x linear. It will be easy to you to solve this one. So I would start, if I were you, I would start for y, because y is not linked to np. Okay, but also I can do for x, because x here is linear. So here it is very easy to solve for y or x. If you go for p, it will be very complicated for you then to find the solution at all. Okay, now how to see? How about this one? Well, also, so see, here you have x linear, y linear, y linear. So you can go, okay, you can go for x, solvable for x, or solvable for y. But remember, if we are solving for y or for x, first we have to apply this change here, okay? P is equal to dy by dx. P is equal to dy by dx, it will be xp, then minus y plus x times these guys, and minus y, and so on and on. Here you can solve for y or for x. Y, x are linear, and it's easy for you to solve. Okay, and again, okay, here we have p squared plus px minus y equal to 0. So here, it is the kind of solution, it's a kind of the exercise that you can try both. Okay, you can try these three ways. You can try by x. Okay, you can solve by x because x here is linear. Y is linear also. You can try by x. You can try by y. Okay, yeah. Or you can try also by p, because p here is a polynomial like this. You can see. So you can come here and try. Okay. Okay, but see, whenever you have p squared plus px minus y, so if you want to see whether I can solve for x for p or not, just try to find, consider this as a common like second degree equation. Okay, second degree equation. Just compare with ax squared plus bx plus c. Okay, and see if delta is going to be a function or is going to be a term that you can reduce. Okay, a term in square, like something that you can reduce in a square, perfect square. Okay, suppose here if I consider this one as a, b, okay, b will be what? X, and c will be minus y. So it will be b squared minus 4ac. So here you get b is x squared minus 4. What is a? 1. What is c? Minus this. So minus y. So minus y here. If you see this word, this will be x squared plus 4y. Do we can just separate? Do we can like make it a product, and this product can be all in square? No, not possible. So forget about solving for p. Okay, but this case we just apply when this is what? This is a equation of second degree equation. Okay, yeah, we can check like this. We can check like this. Okay, we can check like this. This is one of the way to check this one. You can also find other ways. Okay, so see, p squared plus px minus y equal to 0. So another way to see whether this is solvable or not is transform this guy in a quadratic equation, in a perfect quadrant, like a plus b x squared. As here we have plus, then we can transform in that way, and so on and so on. But anyway, okay, anytime you try to transform this one, you will not get this guy as a factor in this common expression. So you are going to use definitely order either by x or y. You can solve this one by x or by y. If I were you and I would like to get an easy time, I would solve this one for y, because y has nothing multiplying them. Okay, but you can also solve by x. And how to solve by x? Just follow all this steps. We are going to solve this guy. We can okay, we are going to solve by x this one, by x. We can solve by x this one. Okay, and sorry, we will solve this by y. This is easy one because nothing is linked to him. Okay, it's perfectly isolated, so I can go for this. And see, y squared ln of y equal to y equal to xy dy dx and dy dx. So there. So see, here it's p squared, p, then it's x. Okay, then it is y, then it is y squared ln of y. So how to use or how to choose here which element we should work with? See, here it's very clear. Look for linear. Y square is not linear. Ln of y is not linear. It means that y, whenever you see y here, it's impossible. It will be not impossible, but it will be difficult for you to solve for y. So go for x, because x is linear here. This is not linear. It's not linear. So x is linear. You can solve this directly. Okay, the most easy, the easiest way to solve this is going for x, okay? Because y is not linear, dy by dx is not linear also, that is p is not linear also. So go for x, it will be easier to use. So you get for x, okay, this one we can solve for x. Okay, for x, it will be very easy for you, okay? This one you can solve c. To be very easy for you, just solve for y. Why for y Veloso? Because y has nothing linked to him. So it will be easy to differentiate, okay? And to separate them, okay? Why can't we solve? We can solve also for x, okay? In this case also, if you can see, here it's easy to separate or to solve for y, okay? Even though you can also solve for x, but it's very easy to solve for y because y has nothing linked to him, okay? You can solve for y, okay? Here only for p is possible. Here you can solve for p. P will be more easy, will be easier for p. Y Veloso, because x here is not linear, so it will be complicated to you then after, okay? Okay, so let's go again. Here, as I said, okay, here you can solve by x, okay, or you can solve by y. But see, as I told you, x is linked to this guy. Here also, you can see like y and x, and this is all linked. So, it's also linked. This y is separated. So, you can just take common this y and this y and solve them with respect to p and x. Or you can take common x and solve for y. Okay? And solve for, take x and separate x, take common x and solve for x. Okay? This one, both sides will be easy for you. Okay? So the level of difficulty is the same. Okay? You can solve for y and x. What else? Now let's see. This one for x will be the best way. Okay? The best way. I don't mean you cannot solve by y or by p, okay? Because there are many ways to solve. But I should like, if I were you, I would go for x, because x is the only linear here. It's easy. Now here also, see, x is the only linear here. I would go directly for x, because this way will be p squared ln of p. So go for x. Then here, p squared, 2x, 2y, p, and 4xy equal to 0. This expression or this equation here, if you find, this is p squared, right? If this is p squared, so you can apply this, you can compare, if you feel like, okay? You can compare with this expression that I did last time, okay? This is your b, this is your c, okay? This is c, this is your b. And this is a function of p. Okay, it will be p squared plus b, and this is plus c. Okay, then find your delta. Your delta here, you will 2x plus 2y, okay, squared. Do not forget, anytime you have this p squared, okay, you have here a polynomial of p, okay, and this is p squared, 2x, 2y, and so on. You can solve, okay? You can check whether you can solve by p when this delta gives you a number that can be reducible to a square, okay, like this one. You can see 2x plus 2y square, that is your b, minus 4a, the coefficient of p square, that is 1, and your c is 4xy. Check. So if you check this one, this will be what? This will be 4x and this, okay? This will be 4x squared plus 4y squared, okay? Plus twice this and this. This will be twice this and this. This will be what? 8xy minus this and this will be what? Will be 4 times 4. 4 times 1, 4. 4 times 4, 16xy. Then just solve this one. What you are going to have, okay? This one. If you take common 4, 4, 4, you get 4 here out. You're going to get x squared plus y squared. And here, if you take common 4 will be 2xy, and here 4xy, so it will be minus 2xy, just like this. So here delta is equal to 4 times, if you check this expression like this, okay, this is the same as x squared minus 2xy plus y squared. So this is the same as I write 4x minus y squared. Now see, this is 4. 4 is also 2 squared, so it will be 2, okay, 2x minus 2y whole squared. As long as you can, okay, if you can do this one, so you can just solve for p, then find your p, and so on and on. Okay, you can do it this way because it is a quadratic equation, but you can also apply some artificial. Okay, so this is a case, this exercise is a case that you have x linear, y linear, x linear, y linear. Okay, this case you can work for these three methods directly. You can work either for p, either for x, either for y. Okay, these are solvable for all of them. Okay, yeah, because we know that for here it will be easy for us to take it. Okay, it will be easy for us to take it. It's like okay, if I want to solve for x, I just solve for x also. So this one is for x. Do not forget, you can go for x. This one can be for p, for x, and for y. You can solve all for this one. Okay, the other manner that you can find this one, you can just find this guy, is doing what? It is p squared plus, take 2 common, 2x plus y, and here p plus 4xy. In this way, I will just apply some, how can I say, some mathematical artificial, okay, mathematical artificial, like if I have here p squared, 2x plus y, and p, what does it mean? It means that, suppose I want to get this one, a plus b squared, that is a squared, plus 2ab plus b squared. Now, I will get this one as p squared. This is 2, okay, 2a. See, this is 2a. So it will be my b. So what do I need to get this one, a plus b whole square? What do I need? I need this b square here. So this is b, so it will be b squared plus 2 xy b plus this one, x plus y squared. Now that I add this x plus y squared, I have to take x plus y squared. Then put this one plus 4xy, then equal to 0. You see? Then by this way, you are going to get this one. It is this is p plus b, a plus b, a plus b. This is p plus x plus y, okay, square minus, and this expression, if you see, it will be x square, okay, negative here, x square minus y square, then minus 2xy plus 4xy, okay, equal to 0. Okay, with this artificial, I can just directly count. So p plus x plus y square minus, just do this one. This and this will be positive. Then take common minus. Minus here, this will be x square plus y square. And here, minus, because this will be positive. 4 minus 2. 2 positive. So when I take common minus, it will be minus 2xy equal to 0. And this is a when I have for a square, b square minus 2ab. So this is the same as x minus y square. And here I will get p plus x plus y square. This is differential, quadratic difference, difference like this one and this one. So when I get these guys, it will be a squared minus b squared. It is a minus b times a plus b. Okay, I hope you can just get this one. I'm solving this way because it's the most complicated way, okay? Otherwise, it's the most complicated, but it's also solvable, okay? But the easiest way is going from x and y, and directly you can solve this one. Then from here, you will get p plus 2x, okay? And p minus 2y, okay? Just by this, then apply this integration and everything, like you will get like an answer. The answer will be like something like ln of y, okay, plus 2 plus x squared, I guess. I'm not sure. It's here. It's also positive, this one. But answer will be something like, let me check just here. Yes, as I was saying, the answer will be here like ln of y plus 2x minus c1, okay, then multiply by ln of y, okay, plus x squared minus c2, okay, minus c2 equal to 0. This will be the answer after you solving for this exercise, okay, done. Okay, I guess there is a mistake here, not ln of y, sorry, here is only y, okay, here it's only y, okay. You can just finish this one and solve this, apply separable method, because this one will be minus 2y, 2x there, okay, then minus 2x there, dy dx, then take this dx there, dy here, so we ln, then okay, ln, and here minus 2x is fine. But for this one, this will be, say ln, this one will be ln, this will be the answer for this guy, and this one will be 2x, and then it's okay, it will be minus 2x, then it will come x squared will come, okay, and there it will be y. Okay, then let us just solve some exercise for y or for p, okay. I will solve just 2 exercises, and the rest you can do it by your own, okay. Yeah, I will take the easiest guys, okay, if I can. So let me go for like any y or x. This is for p, no, I will solve this for, okay, I will do this one for y. For your own, okay, you can solve this one. And what else? Not for y, I want for x, okay, and